In this video, we are going to discuss about the state space analysis of control system. So first is why we use state space analysis. Okay. See, to analyze the control system, till now we have used transfer function or any graphical approach, for example Bode plot, Nyquist plot or root locus. And we all know what is the definition of transfer function. So transfer function is the ratio of the Laplace transformation of output by input with all initial condition is equal to 0, right? So it is a ratio of Laplace transformation of output by input with all initial condition is equal to 0. So what this mean? What do you mean by initial condition is equal to 0? Initial condition is equal to 0 means your system R is in rest position. Okay, so initial condition 0 means your system is in rest position. Okay, but what about multiple input and multiple output? If we talk about multiple input which gives multiple output, can you tell that in such system initial condition is 0 or your system is in rest position? No, right? So for this we use state space analysis. Okay, because analysis what we have done with the help of transfer function, those analyses are done under the condition that system are in rest position, okay, with all initial condition is equal to 0. Okay, but when a system is given by multiple input and it give multiple output, can you tell that the initial condition of the system is 0? No, initially it was at 0, suppose. Okay, initially it was at 0, but once you start giving the input, your system will not consider under the initial condition is equal to 0, right? There will be some initial condition. So for that we use state space analysis. Okay, so state space analysis approach is carried out in time domain. In time domain. Okay, so we all know, we have seen the representation of any system or any analysis in time domain and frequency domain, but state space analysis is only done in time domain. We represent state variable wherein the first order differential term on the left side of the equation wherein the differential term and the terms which is free from different derivatives, and the term which is free from derivatives is in the right side. Okay, is in the right side. So like this we used to represent the state space equation. So the variable which are represented is state variable and average output equation should be written in matrix form. Okay, so you don't need to worry about all this thing. We'll see one by one. It will give more clear picture. Now next is state space representation. So what is state space representation? How we are representing the state equation. Okay, how we are representing the state space equation. The differential equation, I write here, the differential equation is like a d square x of t by dt square plus b dx of t by dt plus c x of t is equal to u of t. Now this second order differential equation is based on approach. Okay, so first with initial condition we determine the initial condition, that is dx of t by dt. We will take it as 0. Okay, we start initially from 0. So x of t is equal to 0 at t is equal to 0. Okay, now let me rearrange this. So we can write this as a double differentiation of x of t in terms of t plus, sorry, this should be equal to 1 by, I'll remove a from here, so I write 1 by a u of t minus b by a dx of t by dt plus, sorry, minus c by a x of t. Now we'll take x of t as x1 and dx of t by dt is x2. Okay, so these are the state variable. Okay, so we'll take x of t as x1, dx of t by dt is x2. Now let me draw this equation here. Let me draw this equation. Now let me draw this one. Okay. So I'll draw this equation. This is, first of all, there is double differentiation, which is nothing but this is x2, right? So this is the double differentiation. We can call it as differentiation of x2. So this will be x2 dash. Okay, because dx by dt kya hai? That is x2. So d square x by dt square will be x2, will be differentiation of x2. Now this will go to the integral block, and what should be the output of integral block? That is dx of t by dt, which is nothing but x2, right? Or x2 or x1 में क्या relation है? What is the relationship between x2 and x1? The differentiation of x1 is nothing but x2, right? Because differentiation of x1 is dx by dt, which is nothing but x2. So this is x1, differentiation of x1. Now this will go to another integral block, and your output will be x of t, which is nothing but x1. Now we'll take this output and multiply this with c by a. Okay, so x of t into c by a. So this minus b by a minus b by a dx by dt, right? So dx by dt into b by a. Okay, so 1 by a u of t minus b by a dx by dt. So I'll put here 1 by a and this is u of t so this is the negative one, right? So this is the representation of this equation. Okay, 1 by a u of t minus b by a dx by dt minus c by a x of t will give you d square x by dt square. Now what are the dynamic equation we got here? What are the dynamic equation we got here? That is x1 is equal to x2, sorry, differentiation of x1 is x2, and what is x2 dash? X2 dash, that is minus ca x1 minus b by a minus c by a x1 minus b by a x2 plus 1 by a u of t, right? So x2 dash is equal to minus c by a x1 minus b by a x2 plus 1 by a u of t. Now we should represent this equation in matrix form. So x1 dash and this is x2 dash is equal to, this should be 0 1. I'll put here first variables, that is x1 and x2. 0 1 because x1 dash is only x2, right? So 0 1, and this will be minus c by a and this will be minus b by a plus 1 by a u of t. So 1 by a u of t. Okay, so this is the representation of, or we write state space representation of given matrix. Okay, thank you.